Alright, we're getting back into section 4.6, where we're looking at the graphs of the other four trig functions. We started looking at cosecant and secant, and in the previous video we looked at the parent graphs, and we looked at how the graphs were corresponded to their sine and cosine, the reciprocals for cosecant and secant respectively. Now we're going to consider possible transformations to these graphs, just as we did with the graphs of the sine and the cosine functions. Now I have written out here the general form here, variables, or I should say constants a, b, h, and k in both of these, where a does affect not the amplitude, because there is no amplitude, it's unbounded, but it affects and stretches or compresses the graph vertically. If the absolute value of a is greater than 1, it's a vertical stretch. Between 0 and 1, it's compressed or shrunk. And of course, if a is less than 0, then we're going to reflect our graph in the x-axis. Now here's key. The period for cosecant and secant, the parent functions, is 2 pi. Just like with sine and with cosine, if we divide 2 pi by the absolute value of what b is here, then we get the new period. So it might be stretched out, or it might be compressed based on the value of the value of b. The bigger b is, absolute value-wise, the smaller the period becomes. Now h and k are still the translations. H is the horizontal translation called the phase shift, and k is the vertical translation, sometimes just called the vertical shift. So we're going to look at a couple of examples here, and I started off here with a graph that doesn't have a translation, but it does have the dilations, the vertical and horizontal dilations. And I also have written down that, of course, with secant, the period is 2 pi. I went ahead and divided by b here to show you that the period of this is now going to be pi over 2. So I'm going to get one complete cycle within pi over 2. And I also plugged in some values here, negative pi over 4, negative pi over 8. Of course, I picked these values because when I multiply by 4, I get values that I have the ability to find the secant of, because I know that the secant and the cosine are reciprocal, so I can find the cosine of those values and of course take the reciprocal. Notice here where the y values are undefined. That's going to be my vertical asymptotes, because we know that we have a series of vertical asymptotes with this graph. So what I'm going to do here is I use pink, is that I'm going to graph my vertical asymptotes first, and they're going to occur at negative pi over 8. Again, we know the basic shape, pi over 8. And this is a little sloppy, sorry about that. And of course, 3 pi over 8, and every, oops, that's a little better. There we go. And so on. And we would have one about here. Now, we know that the graphs are a series of kind of parabola U-shaped pieces that either open upward or downward, and we have here the key values at negative pi over 4, at 0, at pi over 4, at pi over 2, and so on. You can see here that the 2 is going to stretch it out. So instead of bottoming out at 1 or topping out at negative 1, it's going to bottom out at 2 or top out at negative 2. Now, I'm going to graph those points, and remember the 2 is going to stretch it, so it's going to be a slightly skinnier looking U-shape for these graphs. I did not put in so many that I could graph enough points where we could get an exact or a more accurate looking graph. We're just going to kind of make do here, and we're going to graph here at negative pi over 4. We're going to be at negative 2. At 0, we're going to be at positive 2. At pi over 4, we're going to be at negative 2. That's almost the same color there. Maybe I should pick something different here. And pi over 2 would be up here at 2. And so our graph is going to look something along this line here. Now, to get a more accurate shape here of this U shape, I would probably need to plug in a few more points. But for right now, for all intent and purpose, I just want you to see how the period is affected by this number here, and how, again, the way that the graph is stretched or shrunk is affected by this value, vertical. Okay, and it would keep on going like that forever and ever and ever in both directions. Now, this next graph doesn't have any vertical or horizontal dilations, but what it does have, it has translations. And so I wanted you to see that, but I went ahead and in the green here, as you can see, I graphed the graph y equals the cosecant of x, or an approximate graph there. And now what I want to do is take that graph, because I start with the parent graph, and then I do my translations. And notice here, my phase shift is negative pi, or pi units to the left, and my vertical shift is down 2. So do you see the key points here, where it bottoms out and where it tops out? Those are the ones that I'm going to use to help me with my sketch. Let's get a different color here. I just used green, so let's use blue here. We'll go ahead and use blue. You should be able to see that accurately enough. So I'm going to start with this guy right here. And I'm going to see how this guy is affected in this little bit here between 0 and pi. Now notice it's pi to the left. So this unit here that I have on my x-axis is pi. So I'm going to go exactly pi to the left. But then I'm going to go down 2. Now here's 1, and here's negative 1, so that's a drop of 2. So this point right here, I put a little x there, is going to go to the left pi, and then down 2, so it's going to go right here. So this curve is now going to be up here, and it's going to look something like this. That's this one. And then you just make the appropriate shift here for each one of these pieces. So like this one here is going to, this point right here on this curve is going to go to the left and then down 2. 1, 2, down to here. And if you have a steady hand, which I apparently do not, you can get the rest of the branch, hopefully, in a nice, smooth, accurate looking curve. So this is going to go over to here, and then down 2. This one over here is going to go to the left, and then down 2. And we just continue this pattern. This is going to be to here. Let's see. And then down 2. And so on, and so on, and so on. And we can continue with this pattern here. Down 2. Try to be a lot neater than I am doing right now. And that's the graphs, at least involving some transformations for secant and cosecant. Take your time. If you have vertical and horizontal stretching and shrinking, my suggestion is make a T-chart to get started with that. But once you have that, graph that, and then if there's any translations on top of that that you need to do, then from that first part of your graph, then do your translations. Just do it in two phases there, rather than trying to get it all done in one graph. And now what we're going to do is we're going to go into this next video. We're going to be looking at the graphs for the tangent and the cotangent, and if we have the ability to, maybe we'll look at some transformations that involve those two graphs.